Hey everybody, this is a video that I'm making to help us get through a couple of assignments. Um, we want to finish the one that was on the mean value theorem and antidifferentiation, and then there's one that I made for the second derivative that we went over on Friday, or today if you're looking at this now. Forgive my voice, as you know I'm coming down with something. So I already started this a little bit here. This is the mean value theorem problem where you have an inverse trig function or an arc trig function. This is arc cosine, and this is your interval. And so we have to remember the mean value theorem says that f prime of c, the derivative at some value c, is equal to the slope of the secant line, which I'm going to call MAB. Okay? So again, I have an arc cosine. This is my A, this is my B. So if I find the slope of the line going through these two endpoints, then that needs to be equal to the slope of the tangent line somewhere within the interval in here. Okay? So f of b is cosine inverse of square root of 2 over 2, which is pi over 4. So just ask the question, what angle do I plug into cosine to get this? And it's 45 degrees. What angle do I plug into cosine to get this? It's 3 pi over 4. Now you can ask me in class why it's 3 pi over 4 and not negative pi over 4, because there's two answers for each ratio that I put in. For example, here there's one up here, and down here that'll also return square root of 2 over 2, but you have to restrict the range to only half the circle so you don't get multiple answers for these inverse trig functions, but we could talk about that in class if it's confusing to you. Alright, so MAB, which is this, what is that? It's pi over 4, f of b, minus f of a, and that gives me negative 2 pi over 4 on the top. 1 over the square root of 2 is square root of 2 over 2, which I wrote right here, and then subtract negative square root of 2 over 2, which is what this is, and then I get just square root of 2, and then that's going to give me this. Okay? That's my MAB. Now, I need to take the derivative. F prime of x, which is what? What's the derivative of inverse cosine? Just apply the formula. Inverse cosine, or arc cosine, is going to be negative 1 over the square root of 1 minus x squared. Okay? So now I'm claiming that there's a value within that interval that will an x value that I could solve for that'll be equal to, so that this will be equal to negative 2 pi over 4 times the square root of 2. Alright, so we have negative and negative, so let's drop the negative since they're on both sides. And then let me flip this side and then flip this side. Same thing as cross multiplying. I just think it's a little faster. So then we get what? Square root of 1 minus x squared is equal to 4 times the square root of 2 over 2 pi. Okay? I'm going to square both sides. This cancels this cancels, well, that doesn't cancel, then a bunch of stuff is going to be squared. 1 minus x squared gives me, well, this is going to be 16 times 2 over 4 pi squared, right? Simplify this down a little bit. This is the same as 16 over 4 is 4, so this reduces to 4. 4 times 2 is 8 over pi squared. Okay? So now let's subtract 1 from both sides. So I have negative x squared is equal to 8 over pi squared minus 1. And then finally, well, not quite finally, x squared, if I multiply both sides by negative 1, then what do I get? I get 1 minus 8 over pi squared. Remember, this is all a number. Pi is a 3.1415. It's irrational. So when I take the square root of both sides, if I take the square root of a number, I have to put plus or minus. So I have two answers. X is equal to the negative square root of 1 minus 8 over pi squared, and then the positive square root of 1 minus 8 over pi squared. So it's just some, it's ugly numbers, but you do need to learn to work with these, um, because it's part of the game. You got to be good at your algebra. So I know you don't have exactly the same numbers, but it's either inverse cosine or inverse sine, and you're going to get negative square root of something and negative and the square root of something else. There's going to be a pi squared in there, so it's very similar. Okay. All right. Next thing, number 5. So number 5 was this is where we were dealing with increasing and decreasing intervals and local maxes and mins. So number 5 for me said that f of x is equal to 2 over x. So I want to figure out where are the local extrema. To do that, I take the derivative, as we've done. I mean, again, 2x to the negative 1. So I get negative 2x to the negative 2 equals negative 2 over x squared, and set it equal to 0. What I find is that there's no x value that's going to make this 0. So I think of the question that I'm asking. I'm saying I want the tangent line to be horizontal, so that way I have some sort of a turning point, right, or an extrema. But it doesn't have an answer, so that means there's no extrema, right? So that's your first answer, so pick C. Second thing, there is a critical number though, because the definition of, I'm sorry, there is a critical number, because the definition of the derivative of a critical number is either the derivative is 0 or the derivative does not exist, which does happen when x equals 0. So we have to look at that and see how the graph is behaving, because its behavior may change on one side of that critical number to the other, even though it's not an extrema, so the graph isn't peaking or valleying or whatever. So we got some sort of an asymptote. Okay, so let's plug in something to the left of our critical number. So our critical number is 0. That's where the graph does not exist. There's a vertical asymptote there. And okay, so if I plug in f prime, something to the left of 0 is negative 1. Okay, so I have negative 2 over negative 1 squared, and I get negative 2. So this is negative. That means the graph is decreasing, right? It's decreasing from negative infinity, 0, and I don't include 0. Why don't I include 0? Because I can't plug 0 into the original, because then I would get 0 on the bottom, so I don't include it. Now we got to plug in something to the right of our critical number, something to the right of 0. F prime of 1 gives me negative 2 over 1 squared, which is negative 2. Again, negative. So that means it's decreasing right after 0 all the way till infinity. So how do I put these together? I'm saying that this function is decreasing all through here, but then right at 0 there's a vertical asymptote, so I can't say what its behavior is. I just say it's not defined or it doesn't exist. This function looks like this, by the way, on this side. And then on this side it starts to decrease immediately after 0, which, because the function looks like this. So the way I write that, the way I tape these two intervals together is with the union symbol. So I say it's decreasing from negative infinity to 0, which is this piece, union 0 to infinity. And that's my answer. Okay? The union means I have to exclude something. I have to exclude a piece, and that little piece is 0. Okay, good. Alright, next, number 8. It's asking what antiderivative, or what are the antiderivatives that will give me this for the derivative. So, hold on. Number 8. Let me make sure I copy that down right. This is not number 8. Oh, I'm sorry. This is number 9 for me. Okay. So, find all possible functions with this given derivative. So that means if I think backwards, all right, I need something that will give me this derivative. So again, the rule is add 1 to the power, because we subtracted 1 from the power to get the derivative, so now I'm going to add 1 to the power. and then divide by that new power, which is 3. Add 1 to the power, so this is power of 1 plus 1, and then divide by the new power, which is 2. Add 1 to this power, this is x to the 0, so I'm going to add 1, and then divide by the new power. So then I get, these cancel, I get x to the third, and then minus 3x squared minus x. Okay? But this is one possible antiderivative. If I tack on any number that I want, 7 or 27 or pi or whatever, it's going to go away when I take the derivative. The derivative of a constant is 0. So I say any constant that I add to that will also work. So this is the answer. It's any function that looks like this plus a number works. So that's what they're looking for there. The only difference between that one and number 12 is that number 12 is asking you to figure out specifically what that c has to be. So let's run through it. So my number 12 says that p prime of x is equal to negative 18 over x squared. Let me write that as negative 18 x to the negative 2. Okay, so x to the negative 2, if I'm thinking backwards. So I add 1 to the power and then divide by the new power, which is going to be negative 1. So my antiderivative, or the original function in this case, is going to be 18x. Simple. I'm sorry, 18x to the negative 1, which is 18 over x. All right? But I have to remember there's a plus c there, because anything, as long as this is just a number, will work with this term. But now they give me specifically a point that the curve must pass through. So what that point does is it fixes this constant to something specific. It means I can't just say it's anything that'll work. It has to be a specific c, like 7 or 12 or something. So how do I do that? Okay, I say, well, p of 1, which is 18 over 1, plus c, has to end up being this y value. So p of 1 has to be 24. Okay, so that means c has to be equal to 6. So my answer for the specific one that works, since it has to be the antiderivative of this, and it has to go through that point, is 18 over x plus 6. I just plugged this back into here, and there's my answer. Okay? Good. Next assignment. So what is the meaning of the second derivative? Remember, the second derivative talks about concavity. So let's look at this example here. It says find where things are 3 minus 2x squared minus 5x. Okay, so we got to figure out where the concavity changes, right? I'm sorry. There we go. Okay, so where does the concavity of this thing change? The first derivative is telling me what the slopes of my tangent lines are. The second derivative says this function, it's going from concave down, right, to concave up somewhere, if it's doing that. Some functions don't change concavity, like this function here. This is always concave down. See? Always concave down. So take the second derivative, first derivative, and we get 3x squared minus 4x minus 5 over 3. These cancel. Now I got to take the derivative of that, so y prime prime is going to be 2x minus 4. Set that equal to 0. So I'm looking for, do I have any inflection points, right? Is there anywhere where it goes from concave down to concave up? Turns out I do. X equals 2. Okay? So now, okay, so let me write this on an x-axis. I need to plug in just like the first derivative, except now I'm talking about concavity. What's happening to the left and right of this inflection number? So if I pick 0, make our lives easier, y prime prime of 0 is going to be 2 times 0 minus 4, which is negative, right? I'll end up with negative 4. That means it's concave down before I get to 2. Some teachers like to put a minus sign. Right? Just draw a number line, then put a minus sign if it's concave down, plus sign if it's concave up. Plug in something to the right of 2. Try 3. 2 times 3 minus 4 is equal to 2. This is positive. So that means it's concave up on this whole interval. So the interval for which it's concave down is from negative infinity up until 2. And then it's concave, so concave down. And then concave up from 2 to infinity. So I select for me concave down negative infinity to 2 and 2 to infinity. It's B for me. Okay? Alright, let's try number 3. Alright, number 3 is the same idea, just you're working with an e function. So I have f of x is equal to 15x plus 15e to the x. So f prime of x is equal to 15 plus 15e to the x, right? I'm not going to go, I'm going to move quickly. You need to know your derivatives of e to the x. So then this is just 15e to the x again. Now I'm going to set this equal to 0. Now, this is where you got to know your algebra. Part of college algebra, algebra 2, or pre-calculus, you had to memorize the behavior of functions. The behavior of this function should tell you that there is no number that I can plug in that will give me 0. This function has a horizontal asymptote right here, right at the x-axis. So I can't get 0. So since there's no solution to this, there's no number, that means no inflection point. Okay, well that means that the function is never changing concavity. It's either always concave down or always concave up, but it doesn't switch anywhere, okay? So what do we do? How do we figure out what its concavity is? Well, just plug in a number into the second derivative. Let's try 0, right? 15e to the 0 is just 15. Well, it's positive. So that means this function, and I drew the function already, is concave up the whole time from 0 to infinity. So the first thing is you select it does not have an inflection point. The second thing is it is, for me, it is concave upward on the interval from 0 to infinity. So I'm going to select parentheses. No, I'm sorry, negative infinity to infinity, not 0 to infinity. And there we go. Okay? Number 5. Alright, this is just a graph question. Actually, I don't think I can do this one because you can't see what I'm looking at. But we did several graphs in class, so you're just trying to figure out where's the f prime of x being 0 is where does it have horizontal asymptotes and vertical asymptotes. Well, I can kind of draw this. Hold on a second. For me, I have a cubic function, so it looks like this. Right there. Okay? So f prime of 0 it'll happen here and here, right? So you're going to have two answers. And then these are not going to be points, these are just x values. So, and then it's going to ask you where's the concavity 0 or positive. I'm sorry, where's this positive and negative? So like here it's positive, here it's negative, and here it's positive. And then where's the inflection point? The easiest way to do that is to figure out where's its concave down and then up. So it's concave down here, it's concave up here. So the inflection point has to happen in between these two. It's going to be right at 0. you do got to be accurate with this one. I know I said in class you don't have to be that accurate, but they're looking for you to figure it out here. So figure out the concavity first. Down and up, then here. So it has to happen somewhere in between. It's going to be right at 0. You'll get the intuition after a few tries. Number 6, second derivative test. This is a really nice. I like it because of it shows you understand what's going on if you can come up with a more efficient way to solve a problem. The first derivative test works to figure out where the extrema are, but this is even faster. If f prime of x is equal to 0 and this is negative, then I must have, let's say, that means it's concave down, so I must have a max, right? If f prime of x, I'm sorry, just f prime of x is equal to 0 and the second derivative is positive, then I gotta have a min. So let's look at number 13. I'm sorry, number 13, number 6. So this is f of x equals negative x cubed plus 6x squared minus 18. First derivative of x is equal to negative 3x squared plus 12x equals 0. So solve for x, I can factor out I can also factor out a negative 3, so I'm going to get x minus 4 equals 0. So it's 0 and 4. 0 and 4. X equals 0. X is not a point. This is two x values. So what are they? Okay. Oh, it does ask for what are the coordinates of the extrema. So the extrema, you have to plug it back into the original. So f of 0 is going to be negative 18. So 0, negative 18 is one of my answers, one of my coordinates. And then the other one is 4. So 4 cubed is 64. So I get 32 minus 18. 32 minus 18 is 14. So it's going to be 4 comma 14. These are my two extrema. Now I got to figure out what type of extrema. So all I got to do is take the derivative again, which is nice because the powers go away as I take more derivatives, and then plug in the x value. So since f prime prime of 0 is positive, right? If I plug in 0, I just get 12. Then that means this must be, it's concave up, so this must be a, sorry, this is concave up. I can't do it with my hands. This is concave up. Alright, concave up, so this is a min, right? What's f prime prime of 4? Well, it's going to be negative 24 plus 12, so this is going to be negative. So that means this thing is concave down, so that means this is a max, right? So let me enter that in just to check. We're going to get 0, negative 18, and then 4, 14. Whoops. Alright. And well, that's all it asks. Okay, so it didn't even ask you to. Pfft, stupid question. Okay. Didn't ask you to figure out if they were max or mins, but there you go. Alright, and then number 7, again, is a little bit of a challenge because you have to do a product rule and stuff. So I'll just give you that hint, and I'm gonna let you try because this video is getting kind of long. So number 7, you have y is equal to x e to the x over 8. So your first derivative is going to be, this is my u, this is my v. It's going to be u prime is equal to 1, v prime is equal to 1 over 8 e to the x over 8. So I end up with u prime v, e to the x over 8, plus x e to the x over 8 over 8. Second derivative. I run into the same issue here. I'm going to have to do a product rule again. So try it out. Have a good weekend.